All right, so today we're going to talk about absolute value inequalities. First, let's talk about what an absolute value inequality is. An absolute value inequality is going to involve absolute value symbols. So those are going to be these up and down bars right here. Right? When you see these up and down bars, your goal is going to be to get this whole thing, whatever's inside the upside down bar or the up and down bars by itself on one side. And then you're going to have to do something special to it. This is an absolute value inequality because it has these absolute value bars. What is not an absolute value inequality would be something like y is greater than 2. This would just be a regular inequality. Or y plus 5 is less than 7. Just a regular inequality. Right? Like with this guy here, you would just, subtract your 5 off both sides. Y is less than 2. Go about your day doing the stuff. Right? Your interval answer would be negative infinity to positive 2. That's going to be a regular inequality. You do not treat the absolute value inequalities the same way that you treat regular inequalities, and you can expect to see a little of both on the exam. So let me erase this stuff because that's not relevant to what we're doing. We're going to talk about absolute value inequalities. Absolute value inequalities. The important thing is the direction in which your inequality is facing. So notice that this is y is greater than 2. If you have a greater than symbol, you're going to separate it into two inequalities. The first one is literally just the original inequality without the absolute value bars. I just took off the absolute value bars. Or your second one will be y, flip the direction, make it negative. So y less than negative 2. On a number line, negative 2, positive 2, open circles because there's no underline. Oops. Sorry. And then your interval notation answer would be negative infinity to negative 2, union 2 to infinity. Now, if you're watching me give this answer right now and you're like, that doesn't look very familiar, I'm not quite sure if I'm comfortable with that, please take a look at my interval notation video because I go over how all of those open circles, closed circles work, and how I got this answer down here. This is our interval notation answer. So if you're uncomfortable with getting from here to here, definitely take a look at that video first because I'm not going to go over that in detail in this video. So this is what you do if you have a greater than symbol and an absolute value inequality. Now, if instead we had something like x is less than or equal to 7, so we have a less than symbol, for this what we're going to do, we're going to sandwich it. So I'm going to do negative 7 less than or equal to x less than or equal to positive 7. So when it's a less than symbol, you take this number, make it negative, then you just keep the direction that this guy's facing. So less than or equal to x, less than or equal to 7. On the number line, we'll have closed circles because we have underlines. And it's just this middle portion here. Our interval notation answer will be negative 7 to positive 7 in square brackets. So in general, what ends up happening, and this is in general, I'll talk about the two exceptions, but in general, what ends up happening, if you have an absolute value is greater than a number, you end up with two tails, and you're going to have like a union in your answer. If you have a less than symbol, you tend to get just this middle section here, and just one part for the interval answer. So for the exceptions, there are two exceptions. Let's say I have the absolute value of z is greater than or equal to negative 12. Now, you might think to yourself, and it's completely valid to think this, like, oh, well, that's a greater than symbol, right? So I'm going to split it up into 2. What you have to be careful of is if there's a negative on this other side, once the absolute value is by itself, you have to be careful. So this is saying the absolute value of something is greater than negative 12. But if you remember, absolute values, those make things positive. The smallest that this thing could possibly be would be if z was 0. This would be the absolute value of 0, which is 0. And that's greater than negative 12. Anything you plug in here is going to be an absolute value. It's going to be greater than negative 12. So this guy right here, his solution is all real numbers. On a number line, that's like literally just the whole number line. And interval notation would be negative infinity to positive infinity. On the other hand, if we have, let's say the absolute value of w is less than negative 5. So you may think to yourself, hey, that looks a lot like this up here, right? Just sandwich it. Once again, if there's a negative over here, you have to treat it differently. There's no way I could plug anything in for w and have it be less than negative 5 because this side over here is always going to be positive or 0 at the smallest. So nothing I plug in over here is going to be less than negative 5. That's just not going to happen. So for here, there's no solution. Right. Sometimes we use like this little empty set symbol to denote that there's no solution there. So it's kind of like the basics. Those are the basics of absolute value inequalities. Let's kind of go into more of the nitty-gritty algebraic manipulation type things. All right. So let's say we have something like the absolute value of x plus 6 is less than or equal to 21. The important thing now is that the absolute value is by itself. If the absolute value wasn't by itself, I would do algebraic manipulations to make it so before splitting it up at all or manipulating it. Now I have a less than symbol, so that means I'm going to sandwich. And the way I like to think about it, I like to think like one inequality is less than two inequalities. So if it's less than, it's 1. If it's greater than, it's 2. But, whatever works for you. This is going to be a sandwich, and I'm going to do negative 21 less than or equal to. Now everything inside of those absolute values is going to be in the middle, less than or equal to 21. To get x by itself, I'm going to subtract 6 because I want to get rid of this 6 right here. So negative 21 minus 6, that'll be negative 27, less than or equal to x, less than or equal to 15. So that's negative 27 to 15, interval notation. And on our number line, negative 27, 15, closed circles, bam, just like that. If instead we had the absolute value of x plus 6, so the 6 is on the outside of the absolute value, less than or equal to 21, before we can do anything, we have to take care of this 6. We have to get rid of this 6. We can't split it up. We can't do this thing until the absolute value is completely alone on one side. So I am going to subtract 6 on both sides. The absolute value of x is by itself now, less than or equal to 15. Now I can sandwich. Negative 15 less than or equal to x, less than or equal to positive 15 on a number line. Here we go. It's going to look like this. And there's your interval notation answer. So let's keep going. Let's do some more. Let's say we have a 2 out front. We have 2 absolute value of x greater than 14. This 2 needs to be taken care of before we have the absolute value alone. So if we started here, we would be dividing both sides by 2 to cancel out the 2's. We have the absolute value of x is greater than 7. This is a greater than symbol. That means we split up into 2 inequalities. One is x greater than 7. The next one is x less than negative 7. Okay. And once again, when you have these 2 inequalities, if it's a greater than symbol, it's going to just kind of go off in the tail directions, just the tails of the inequality. As an interval, this is negative infinity to negative 7, union 7 to infinity. So that's if you have that 2 out front, if you have something being multiplied outside of the absolute value inequality. Let's keep doing some examples. because I want to talk about the kind of weird things that can happen here. So if you look at this problem, the absolute value of y plus 18 is less than or equal to 8. You might think automatically, oh, this is going to be a sandwich situation. I'm just going to sandwich it. It's going to be fine. Please remember, you got to take care of this 18 first. So I'm going to subtract 18. I have the absolute value of y is less than or equal to negative 10. That's not going to work for us. We can't have an absolute value be less than a negative number. This is going to be a situation where there's just no solution. Right? Even though we had a positive number up here, after we had simplified, after we'd gotten the absolute value completely alone, we ended up with a negative. So even though there was a positive here, that doesn't matter. It matters what it simplifies to. So there's no solution for this guy. All right, let's do some more. So let's say we have the absolute value of 5v plus 10 greater than or equal to 15. The absolute value is by itself right now. That's just the absolute value on the left-hand side. It's a greater than sign, so I'm splitting it into two separate equations. 5v plus 10 greater than or equal to 15, or the other equation, 5v plus 10, that'll stay the same, less than or equal to negative 15. And you're going to solve each of these separately. So over here, subtracting 10 on both sides, you get 5v greater than or equal to 5. Divide both sides by 5. V is greater than or equal to 1. Over on this side, subtracting 10 on both sides. You have 5v is less than or equal to negative 25. Divide both sides by 5. V is less than or equal to negative 5. Okay. So here's negative 5. Here's 1. Kind of scribble out those tails. So negative infinity to negative 5, union 1 to infinity. I know it feels like a lot, but once you get the hang of it, it's not that bad. Let's try 6v minus 6 less than or equal to 12. So first of all, absolute values by itself, this number's positive. If it's a less than symbol, that means that we're going to sandwich. So I'm going to do negative 12 less than or equal to 6v minus 6 less than or equal to 12. I'm going to get rid of this 6 right here first. And you're doing it to all three sides. So negative 12 plus 6 will be negative 6, less than or equal to 6v, less than or equal to 18. Now my issue is with this 6 right here on the v, because I want it to just be a v by itself. So I'm going to divide everything by 6. I get negative 1, less than or equal to v, less than or equal to 3. Negative 1, 3, closed circles because there are underlines. And our interval notation answer is negative 1 to 3. All right, so let's just go through some more examples. This is basically, if you're feeling comfortable at this point, then you're in a good position right now. I'll go through some more difficult examples, but that's kind of it for this. So let's say I have negative 5 minus 5w less than 15. All right. Absolute value is by itself. It's a less than sign, so I am going to sandwich. I'm going to do negative 15 less than negative 5 minus 5w less than positive 15. I am aiming to get this 5w by itself, so I'm going to add 5 to all three sides to get rid of this 5 here. And you do have to do it to all three sides. Negative 15 plus 5 is negative 10, less than negative 5w, less than 20. I want to get this w by itself, so I'm going to get rid of this negative 5 by dividing everything by negative 5. Now, when you do this, when you divide by a negative, you do have to flip the direction in which your inequality is pointing. All right, my W's here. 20 divided by negative 5 is negative 4. Negative 10 divided by negative 5 is 2. To maintain the meaning of this inequality, but write it in the more natural direction. The more natural direction is having it be less thans in both places. Smaller number, less than, variable, less than, bigger number. To make this more natural, I'm going to write the negative 4 over here, and I'm just going to maintain the meaning by making sure that this is pointing towards the negative 4, so the inequality should point towards the negative 4 when I rewrite it. And like here, the big end should be towards the 2. So negative 4, pointing towards it, W, 2. It's just a little bit more natural to write it that way. So I have negative 4 and 2. It's sandwiched, so it's this middle portion right here. And there's my interval notation answer. Try some more. This one's a little bit more difficult, but I promise it's really just a combination of the things that we've already seen. All right. Here's the big thing that people get caught up on when they see these types of problems. They think, greater than sign, I'm going to split it right away, positive 38, negative 38, bam, done. Careful. This 2 right here and this 4 right here are not inside the absolute value, so we have to take care of those first. You take care of this little guy standing out here first. You're going to get 4 absolute value of u plus 7 greater than 36. Getting rid of that 4 out front, dividing by 4. Absolute value of u plus 7 is greater than 9. Now that the absolute value is by itself, you are going to split it up. It's a greater than sign, so you're splitting. So u plus 7 greater than 9, or u plus 7 less than negative 9. Solving each of these guys. I get u greater than 2, or u less than negative 16. So here's negative 16, here's 2. So greater than 2, less than negative 16. And my interval notation answer is negative infinity to negative 16, union 2 to infinity. So not so terrible, not so terrible. Once you have an idea of what you're doing, these go really, really quickly. Let's say we have the absolute value of 3u minus 24 is less than negative 20. Now you might be tempted, maybe like before, to say, well, there's a negative number here and an absolute value, no solution, because there's a less than sign. Careful. Once again, careful. Always careful in math, right? Always careful. So this guy here has to be moved over before we can make any decisions on whether or not this is solvable. So I'm adding 24 to both sides. I have the absolute value of 3u, now these canceled, is less than negative 20 plus 24 is going to be positive 4. Okay. Now, hey, we have a less than sign, an absolute value by itself. We are going to sandwich negative 4 less than 3u less than positive 4. We want to get the u by itself, so we will divide everything by 3. We have negative 4/3 less than u less than 4/3 on a number line. And you don't need to plot any other numbers besides the numbers you're interested in. Oftentimes it just confuses the students a lot more if they start to plot like 0 and 1, 2, 3, just plot the things you're interested in. Save yourself the time, the effort, and the possible confusion. So there we go. We have our number line graph and we have our interval answer. All right. So let's say we have 9 times the absolute value of v plus 2 minus 3 less than negative 21. All right. Here, I'm going to be adding that 3 first. So I have 9 absolute value of v plus 2 less than negative 18. I'm going to divide both sides by 9, but right now, even before I divide by 9, I know that dividing by 9 is not going to change the fact that this guy right here is negative. It's not going to change the fact that this whole number is going to come out to be negative and give us a problem. But I'll do it, right? Absolute value of v plus 2 is less than negative 2. We can't have an absolute value be less than a negative. Now, we're stopping here and we're going to say there's no solution, not because up here there was a negative number, but because when we got it by itself, this was a negative number. So if it's an absolute value less than a negative, that's going to be no solution. All right. Let's do 5 times the absolute value of u plus 3 plus 8 greater than or equal to 1. Starting with the 8, I'm going to subtract 8 off both sides. We have 5 absolute value of u plus 3 greater than or equal to negative 7. Now, this is another situation where, okay, I know that I need to still divide. I do still need to divide by 5, but I know dividing by 5 isn't going to change the fact that I have a negative number over here, and weird things happen when you have negative numbers and absolute values. So we have the absolute value of u plus 3 greater than or equal to negative 7 over 5. Every absolute value is greater than every negative number. So if you have an absolute value greater than a negative, this is all real numbers. All real numbers. So you're probably getting the gist at this point. We'll just do one more for, good measure, but this is as bad as they get. This is as hard as they get, Let's do 4 times the absolute value of w minus 8 plus 1 less than or equal to 37. I'm going to start by subtracting 1 off both sides. We have 4 absolute value of w minus 8 less than or equal to 36. Dividing both sides by 4. I have the absolute value of w minus 8 is less than or equal to 9. It's a less than symbol. It's an absolute value. So we are going to sandwich negative 9 less than or equal to w minus 8 less than or equal to positive 9. And I'm going to be adding 8 to cancel that guy out. Negative 1 less than or equal to w less than or equal to 17 on a number line. Negative 1, 17, closed circles. And our interval notation answer is negative 1 to 17. So, that's about it. That's, all you need to know. Going back to this first slide, if it's an absolute value and it's greater than, it's going to split as long as this is positive. If it's an absolute value and it's greater than a negative number, your answer is all real numbers. If it's an absolute value and a less than sign, then you're going to sandwich. And if it's an absolute value and a less than sign and you have a negative number, no solution. I do want to point out really quickly that this applies for absolute values and absolute values only. And I know I said that at the very beginning, but I feel like it's worth mentioning. So if I have 3x plus 7 is less than 2x minus 12, right? This is just a regular old inequality that you're solving with the traditional means. So I can subtract the 2x's on both sides. I get x plus 7 less than negative 12. Subtract the 7, subtract the 7. X less than negative 19. Here's negative 19, open circle, this direction, negative infinity to negative 19. right? You get the gist. And not even just when there's variables on both sides. I mean, you could have something like 5x plus 1 is greater than 2, something like this. There's no absolute values. There's no up and down bars. So you're just solving this. You're not going to split it. It's not an absolute value. You're just going to solve this in the traditional means. Just like that. All right, so please do keep in mind when you're doing these that you need to be careful that you're only using these methods when you have an absolute value and not just all willy-nilly. But that's everything for now. Hopefully that clears up a little bit of the confusion on these absolute value inequalities. And as always, if you have any questions, you're always more than welcome to email your instructor, and we're happy to help out. All right.